Alrighty, we're going to go ahead and get started. First off, I just want to say good morning and thank you for taking time out of your schedules to be a part of the second and final virtual pollution prevention summer workshop entitled Reporting and Pollution Prevention Calculators. That was a mouthful. This workshop is being put on by the Tennessee Department of Environment and Conservation's Office of Policy and Sustainable Practices in collaboration with the EPA. So we have some good information coming today. Some reporting could be a little confusing, so we're hoping we can help clear that up and figure out how to use these calculators a little bit better. So my name is Caleb Powell, and I'm an environmental scientist for the Office of Policy and Sustainable Practices at TDEC, and I'll be hosting the webinar today for our wonderful speaker. Everyone is muted upon entry to reduce the amount of background noise, but if you have any questions, comments, or concerns, please feel free to ask them. This is going to be more of we want this to be more of a discussion based. If you have any questions about the reporting or how to, or what something means, please feel free to shoot that in the chat box. Or there's also a new little feature where there's a little hand emoji. I don't know if you can see where on the right side where there's participants, you can see who's on the call. Below that, in between the participants in the chat, there is a little hand emoji, and you can raise your hand, and that'll let me know that you would like for me to unmute you, and then you can ask that question through your speaker. But like I said, if you don't feel comfortable doing that, or you'd like to just send it without having to talk, then you can send it through the chat box. And what I'm doing right now is I'm going to go ahead and send a chat to everyone. So you should be seeing that in the chat area. It just tells that this is a chat box, and you can feel free to ask your questions and give comments here. So don't be shy and ask any questions that you have. We want this to be a good learning experience for you. So to give an overview of what's going to be covered today, basically, reporting can be confusing if you're unsure of how to use certain calculators and tools that are provided by the EPA. This webinar will be breaking down the pollution prevention calculators and tools to help us better understand how they work. So Kathy Davey is one of the individuals that's actually created these calculators, and she will be able to answer all of our questions and sort of run through how to fill it in, what information needs to go where, and stuff like that. So I don't know about you guys, but I'm super excited to hear about it. They can be a little bit confusing, but that's why we're having this workshop today. So with that being said, I will pass it on over to Kathy.
Well, thank you very much, Caleb. Thank you for hosting and moderating the webinar. Good morning, everyone. Thank you for joining in this WebEx webinar on reporting and US EPA P2 calculators. Webinars have given us a safe way to keep our professional engagements going and socially distance at the same time. So we are super glad to be included in Tennessee's roster of virtual workshops this year. So to introduce myself, I am Kathy Davey. And good morning. I am with the Prevention Strategies and Implementation Branch in EPA's Office of Pollution Prevention and Toxics, which is in that larger organization of chemical safety and pollution prevention. Our branch works with EPA's regional P2 coordinators and project officers to administer the pollution prevention grants and our source reduction grants, and everything about measuring and reporting. And I'd like to give a shout out to an absent colleague, Natalie Hummel, who got the ball rolling, things rolling for us on being involved in this workshop. So we will be using a combination of slides, which are on the screen now, and 3 online P2 calculators for this webinar. We're going to start with the slides, and they're going to focus on our P2 program's reporting requirements and metric standards as they appeared in the request for grant proposals. So this is sort of addressing the piece, once the calculators are used, and we're going to go through that and see what results you can get out of those. And those results need to go somewhere, and they need to ultimately get reported to EPA. So that's why we're going to pick some things out of this slide deck. Now, the P2 calculator tools that we have online cover P2 greenhouse gas calculations, so everything that has to do with energy. We have another calculator for computing cost savings from P2 actions. And we have a conversion tool when we're dealing in the realm of hazardous materials for those liquid hazardous materials, paints, oils, you name it, a handy way to convert from gallons to pounds as a unit for reporting. So these tools are downloadable Excel files on our website, epa.gov/P2. And whenever I mention anything that sounds sort of technical or like I just gave that reference, we'll be sure to work with Caleb to send out any follow-up materials as needed so that you have that information. So we'll begin with these slides on EPA reporting requirements, and we're going to especially focus on the part of the slides that relate to our metric standards. And by this, I mean the kind of recurring questions that arise about what environmental outcomes can be reported and how those questions get answered. I will try to be alert to the differences between the way those questions may get answered for a state leadership program like Tennessee's Green Star program and the way they get answered for reporting to EPA. I will explain at a general level the practical steps that EPA takes to resolve the differences between the decisions that programs like Green Star make in terms of reporting and the decisions that EPA makes with respect to reporting. We will pause for questions and discussions after this relatively short presentation. Then we're going to turn to our online calculators, which I have downloaded in advance. To download these yourself and get them to work, there are a couple of technical instructions to remember, and I think that's the kind of thing that would be great to send out as a follow-up to the webinar. You know, remembering to save and click a couple buttons, that sort of thing. When we look at each calculator, we'll go through them one by one. I'll describe how they are organized overall. There is more or less a consistent organization scheme. And we will take a good paced walk through each calculator. We will pause here and there to make some entries and watch the calculations occur. Caleb will keep his eye out for your questions, as he mentioned, as they arise during the presentation, and alert me at natural opportunities to pause and take those questions in real time. We'll also pause briefly after discussing any particular calculator or further questions. Okay, now let's get started. This is our double duty PowerPoint because it served time for a webinar we gave yesterday on reporting, and it's going to serve us today as well. So we are going to pick through here. Now let me just to go back a moment. The webinar that we gave yesterday covered all of these topics, and I'm just going to mention them because in making this PowerPoint available to you after this presentation, there may be parts of this that you may want to look at even though it may not be the focus of attention today. So we're really going to focus on the second and third item there, which is the scope of reporting and the outcomes that are eligible for reporting. I would just note that sections 4, 5, and 6 in here have to do with the particular reporting requirements that EPA put out in its request for proposals for each of those groups of years and how they have evolved over time and what templates EPA has made available, sample spreadsheets for reporting for various kinds of programs, including state leadership programs. So there might be something in there that you might find interesting, but I'm not sure that it fits squarely within the topic we're covering today. So to move to where we want to go, I'll just note in our presentation yesterday, we reiterated why we think reporting is so valuable. And maybe just focus here that, you know, it's certainly more than an administrative requirement from the way we look at it, because it provides such useful raw data that can be beneficial for the entire P2 community. And reporting enables EPA to assemble what is reported into a database that will be searchable to the broader P2 community and interested facilities, something that is in the works now. So we look at reporting as allowing for an ever-evolving and unbroken chain of P2 knowledge. Okay, this starts to get to the question of what environmental outcomes can be reported and how those questions gets answered. So the way EPA has thought about it and some of the materials it's put on its website is what we call whether they're eligible to be reported. And we think of that in terms of meeting both our programmatic standard and our actual measurement or metric standards. We have had a document on our website that addresses these topics. We're updating it now. It's going to be more or less called instructions to recipients of grants. But that's where this material comes from. And it was referenced in our RFA request for applications or proposals. So that we distinguish from our end, and I only mention this because I think it may become relevant to a point we'll make later, and that is when we award grants through the pollution prevention grants, our statute requires us to give them to assist business facilities. So when it comes to the reporting that takes place between the state and EPA, you know, we're asking leadership programs to exclude the non-business results in reporting to us. And we understand that leadership programs have a wide range of participants that are not limited to businesses, and we appreciate what those leadership programs are doing. We're just abiding by the restrictions that we have when it comes to reporting at our level. Okay, so now we're going to get into the more nitty-gritty on the measures that we have. We're going to go through them one by one. There's the greenhouse gas, achieving those reductions. There's conserving water. There is hazard materials and releases, and then there are the cost savings that can flow from those environmental activities. So first we're going to look at the hazard. And you'll notice that our measure is limited to hazardous material and hazardous substances, hazardous pollutants, and contaminants released. This flows from our statute and the way that statute has been interpreted at the federal level. So we consider eligible for reporting to EPA hazardous materials and pollutants under federal and any state statutes. Now, I think in programs like Green Star, solid waste is a legitimate thing to report. And there may even be questions about what to report and, you know, how it could be reported. And from EPA's perspective, that stuff is all fine. It's just we don't have any particular guidance or interpretation in that area coming out of the pollution prevention program. That would come out of our EPA solid waste program. It would, and so that's a difference between their program and ours. We don't really get into that area. When it comes to reporting air pollution, we would just note from EPA's perspective that EPA has a cap and trade rule for utilities, which means that reductions that are achieved by reducing energy use at one utility are traded to another utility who can maybe go above their limit because they're taking advantage of what somebody else has reduced. So when it comes to reporting the sulfur oxide, nitrous oxide reductions that come from utilities, you have a project where electricity use has been cut back, so it might seem natural to want to report the SOx and NOx reductions associated with that. It just cannot be reported to EPA because of our cap and trade rule. If those are achieved by using boilers less or having a more efficient boiler, cap and trade doesn't apply. It's fine to report those. You'll note that we have a note here on water pollution. I'm not sure whether this is reported in a state leadership program. We consider it a valuable thing. The guidance that we give is make sure that the water weight is not counted as part of the, in quantifying the water pollution, and we give a simple rule of thumb on how to achieve that. One way is to use the facility's water permit methodology, or we accept as a handy approximation dividing the wastewater weight by 50,000. Since we're not a regulatory program, that is adequate for us. And you'll note here that non-hazardous material reductions are something that don't get reported to our P2 program. Okay, gallons of water saved. It's all legit. We just want to make sure people don't count twice. So whether it is achieved by reducing incoming water use, fresh water, whether it is reducing outgoing wastewater released, either way of counting is fine as long as the same water isn't counted twice. If there is a green infrastructure project, the conservation of source water can be counted. I would just note that in the looking at this from the perspective of incoming water used, if water is repurposed from one use to another, so that that second use doesn't have to use fresh water, you know, we count that as water conserved. Okay, so our measure when it comes to energy and so forth are looking at the greenhouse gas side. EPA uses metric tons of carbon dioxide equivalent as its measure for greenhouse gas, which is a measure of CO2 and methane and two others as well. So it's the commonly used metric at EPA. So we ask that reporting to us be in that unit, and this is where our calculator that we're going to be looking at is very handy for doing conversions. I do not know whether this applies to any of the participants, but I will mention it. When the primary is, we're looking at conditionally eligible. When there is work going on at a facility and the primary technical assistance of a pollution prevention kind, and the primary action that is accomplished achieves something on our environmental measures, which are reducing hazards in materials or releases, conserving water, conserving energy, or more energy efficiency. Under those circumstances, if there are incidental non-hazardous reductions achieved, people reporting to us may convert them to our carbon measure and report them. And we have a tool that comes out of our waste program, our solid waste program called the WARM tool, which will do that conversion. We're not going to go over that tool today. It's not directly one of our tools, but it is, I think, pretty easy to use and can be easily found. And if anybody wants more information on it, we're happy to provide it. So the flip side of that is if the primary action that is achieved at a facility is the reduction of non-hazardous materials, then we ask, when reporting to us, that that not be converted to greenhouse gas and not be reported to us. And this is us trying to strike the balance between recognizing that all of these things contribute to greenhouse gas reductions, which is great, but also making sure that the reduction of non-hazardous items does not become sort of a de facto priority of our program. So this is the way that we try to strike that balance for us. And then last, and then after this, we'll have that discussion opportunity. So our metric of saving money, that is associated with achieving one of our environmental outcomes. It's broadly stated. So any money that is saved that way, including from savings from reduced regulatory burden, is eligible, whether it's from achieving reductions in hazardous material use or in hazardous releases, or reductions in water use, and reductions in energy use, or reductions in anything else that achieves greenhouse gas reductions. We'll see that our tool encompasses a few other things. All of those dollar savings that often flow from those activities are counted by us. So the thing that we would just point out is that sometimes work that is done is more about production efficiency, and sometimes production efficiency results in environmental benefits that meet our measures, and sometimes it doesn't. Those actions don't. So if something gets reported to us where there are only dollar savings and there are no achievements in reducing, in achieving our environmental measures, then we ask that that not be reported. And the reason that we do this, again, it's striking a balance. Production efficiency in and of itself, productivity improvements are not the purpose of our program. So we want to make sure that cost savings that get reported to us are matched with the purposes of our program and reflect the environmental outcomes that we're trying to achieve, so that it is a fair assessment of the cost savings that are genuinely associated with our program. And I would also, in the second bullet here, for those cases where it's primarily non-hazardous reductions that are achieved at a facility, we do not want the cost savings, well, actually, whether they're the primary ones or incidental ones, we don't want to see the cost savings from reducing non-hazardous materials or wastes reported to us, because it would have the effect of inflating the value that is associated with the cost savings of our program from activities that are not the purpose of our program. So we have to avoid that distortion, if you will, in the economic effectiveness of our program. So we ask that the cost savings from those things not be reported to us. Okay. So this is an opportunity now to talk about the questions that arise about environmental outcomes to report. And if so, Caleb, I will turn it back to you.
Thanks, Kathy. Let's see. I'm looking through to make sure. Let's see. If you want to, like I said before, if you have any questions, you can, and you want to ask those yourself, or you have some comments, maybe some comments for clarity on something that Kathy had said, then feel free to hit that little raising hand emoji, and I'll unmute you so that you can ask that question. And then also, if you don't want to do that, you can send it in the chat box, and we will get those questions answered for you. And then, like Kathy said, we will be having a follow-up email where we include any of the links to the tools that we're going to be using a little bit later, and just really any resources that we talk about, those will be included in the follow-up. So as of right now, I'm not having any questions. Those might come in a little bit later. I'm thinking that in my mind, I feel like once we start using the calculators and stuff, well, I know that's where I have questions. I'm just thinking for the whole group that might be where some more questions come from. So.
Okay, great. Well, if everybody bears with me, we are now going to technically shift gears here a little bit while I open on my computer my Excel files. And in a moment that my screen should become visible to you. Okay, so we're going to start with sort of the easy, straightforward tool. Okay, so this tool as it exists today is very simple in its purpose. It literally just converts gallons to pounds. So there are a variety of hazardous materials that are in liquid form. So if we look across the bottom of the tabs, they are solvents, fuels and oils, refrigerants, household paints, automotive paints, metalworking, and so forth. See if there's another one. Anyway, the basic idea. So we're going to start on solvents. So the way this tool is organized is that, you know, we took all the common solvents. Actually, 58 of them, I guess. And so this is all based on density. The thing I would note, which will, as we move to more complex tools, the way our material is organized is that we have instructions and a description of the calculations on this particular tab, and then we have references for where we're getting our information. There should be a final tab here with that. So basically, what's going on in the background are density conversions, so that if we enter a value here for 1,2,4-trichlorobenzene, we got rid of using 100 gallons of that. We'll see that it gives what the density is, the pounds per gallon, so you can have a sense of which of these are more dense and which are less dense, and then it converts it to pounds. And so we'll just take a quick look here. Fuels and oils, looking down, it goes through coal and oil and gas and different kinds of oils and so forth, even wood, which granted is not really a liquid, but not quite sure why that's there. Okay, refrigerants. Again, there are a number of refrigerants used. We list them. Household paints is a one-row item. Automotive paints, a one-row item. Metalworking fluids, same thing. Then we have liquids that didn't fit into any sort of overarching category. So they are listed here. Kind of a good range of things there. Materials have different densities. So those, to the extent that they're sold in a gallon format, their pound equivalent is produced here. And then for those who want to understand our sources and where we get the information, we make that available and a reference and justification tab. So this is pretty straightforward, and now I think we can move to the greenhouse gas calculator.
Hey, Kathy, and we actually have one question. Somebody said, does the spreadsheet allow you to add items that aren't listed? So, I mean, this might be, I might should have waited towards the end if you're going to be going over that, but yeah.
Yeah. What items can be listed? We won't have the, so I guess that I could understand that question in two ways. Can a user add a row and add some materials? And I think the answer to that would be yes. If somebody thought of something that we don't have on here and that they think should be on here, we'd be glad to know about it and get the right density and add it. Does that answer the question?
I think so.
Okay. All right. Okay. So the greenhouse gas calculator. We describe its purpose, its function. So I might just point out that the activity tabs here relate to electricity management, green energy purchases, stationary source fuel, mobile source fuel, green chemistry, water conservation, and so the energy associated with pumping water, and solvent remanufacturing, which is sort of a specialty tab. Every tab has a yellow row with an example to show activity metrics being converted to the metric carbon unit reduction. And then we have an aggregate tab. There's some also some explanation here on how this fits in with the scope format in the sort of international, the UN way of looking at greenhouse gases. So we explain ourselves in that way. So we're just going to move to the next page, which is our aggregate. So I'm going to, this is sort of the big picture look. So what this tab does is it takes entries from all your other tabs and aggregates them together. The unifying way these calculators are organized is that there are project rows. So you would decide what is the scope of your project, and then you would use the various tabs. So like if the activity that you were working on reduced electricity use, some of it switched to green energy, some of it was conserving fuel, you'd have a place to do each of those calculations on the tab where those formulas are provided. And then this tab would show you the whole works for your project together. And in column J, it would give you the total value. So you will note that we have color-coded our tabs, that we continue the color coding here to make that association a little bit easier to see. We can come back here. I would also note that we have borrowed something from our cost savings calculator so that it becomes easier for people to directly see the relationship between their energy, between their carbon reductions and their cost savings. It involves understanding the underlying activity unit that produced the greenhouse gas reduction. And the way our tools are set up, if this tab weren't here, is you would have to use both tools because there's two sets of conversions. One from electricity use, which has the cost associated with it, to greenhouse gas. And then you'd have to do the conversion. So you'd always have to go through that electricity unit to get from carbon to dollars. This does it behind the scenes for you, so that automatically, once the computations are done, let's say you're conserving the hidden energy in water management. You know, people don't. It's usually not visible to people what the energy value is that's associated with pumping water, because that's built in here, and because we do have formulas for the dollar value associated with that pumping. This will show that cost savings to you that flow from the energy side of water management. So that's an idea of what we're talking about. You can come back to any of these tabs. We're going to move to electricity management, which is a very commonly used tab. So this tab is organized by cutting back on your electricity use, electricity conservation here. We also, this is getting dated, isn't it? We need to update our calculator, which we hope to be doing this year. This is compact fluorescent light bulbs, but today it's all about LEDs, so we will have to replace this section with that. We often provide an area called Other, so that if there's something that we haven't thought of, but that you know about and have values for, the reason we include it here is that if you're trying to aggregate all the results associated with your project, we don't want to leave something dangling on the side. We want to have a place that you can enter it so that it can you can see the aggregate put together. So let me just, you'll note that we always have how to use the tab. So here, for example, choose the emission rate. Yes, we'll talk about that. And then it basically here walks you through the steps of what to enter. Here, we want to be transparent about how we are doing our calculations. This could be important if you're trying to match, understand what we're doing with how somebody else calculates it. This should make it fairly transparent. So we'll see that it's organized. There's a project, and then we have values that are either, you can either get a state-specific value of what electricity costs in your state. We also have a U.S. national average, which can always be used, particularly if you need a default. So here in our example, we see that a North Carolina facility reduced its electricity use by 10,000 kilowatts of electricity, through new controls and repairing system equipment. So they picked their state, they entered their value, the unit. The units we have are kilowatts, BTUs, and therms. They pick kilowatts. So that was handy. It's the same thing, so 10,000 there. And then here it gives you the greenhouse gas value of that reduction, which is 6.748. Has a lot of numbers on the right side of the decimal. Let me get back to the screen. So we can see it in action here. If we want to pick, say, Tennessee, and we want to just put in a different number. Now, if for some reason you're getting measures in megawatts, there are 1,000 kilowatts in a megawatt, so just increase the number that you enter in terms of the input value. And so we see that that value has now been provided to us in terms of metric tons of CO2. So it's a very handy way to get from an energy unit to a metric ton and CO2 equivalent unit. Let's look at the next tab. So shifting to green energy, description of the tab up here. This takes care of the situation where somebody buys green power, and it can come from a great variety of sources, whether solar, wind, geothermal, biomass, low impact small hydroelectric, biodiesel, fuel cells. We note in our calculations that large hydro sources don't count as green power. If someone buys renewable energy certificates, this tab is also designed to address that. So very, very similar sort of scheme here, where you pick your state, you describe the understand the basis of the, well, you know what your activity is. On this tool, there's no place to enter that because this is simply a calculator. But the unit, the value was selected, the unit was selected, the conversion was done. Again, we provide our description of the actual calculation. So one thing I want to do is I want to go back and clear out well, that'll take care of itself. I'm going to just skip that for the moment. So here again, if we wanted to pick Tennessee, well, not quite sure why we have these here because this should really fall under fuel source. So very typically, if it's energy, electricity management, it's going to be watts. So again, there's our number. Let's try this one. Volume of certificate purchased in kilowatt hours. Okay, well, I guess what if you're purchasing a renewable energy certificate, they give you the kilowatt hour value of it. So it would operate the same way. Stationary sources. This is reducing fuel use and substituting greener fuels. This will take care of both of those. So the description of the tab. For fuel substitution, so if you're reducing fuel use, that's pretty straightforward. If we're doing fuel substitution, you have to enter a negative value for the substitute fuel amount and a positive value for the discontinued fuel amount, and then it will give you the net value of what you've done. So we have a bunch of coal here. We have crude oil, we have diesel, liquefied petroleum gas or propane, we have landfill gas, natural gas, biodiesel. We have examples for a number of these. Biodiesel, natural gas, diesel are the ones we have examples for. Let's just look at those. Easy Energy Company replaced 20,000 gallons of distillate fuel oil in a turbine with 20,000 gallons of biodiesel. So step 1 of 2. See biodiesel for step 2. So they entered 20,000 gallons of distillate fuel. which has a value of 204 metric tons and change. And then if we go over to biodiesel, where they entered negative 20,000 for the biodiesel, well, that was a replacement, which is negative 189. And then if we, the net so it gives, let me try an example. Let's just do 100. Oh, I need to put in a negative number. It's correcting me. So I, for the moment, am not getting this to work. I haven't done this in a while, but it does work, and I could easily follow up on this if this is something that is relevant to you. So we can see here that there's a wide range of fuels that this addresses. Units are appropriate to the item being selected, like landfill gas, therms and cubic feet. So there's a wide range of what can be done here. We can also place the cursor over a cell for more information on it. Let me now move over to mobile sources, where we cover reduced fuel use and substituting greener fuels. This tab presents the carbon emission intensity of fuels from high to low. For travel, you can choose between reduced miles traveled or reduced fuel use, just don't use both. For fuel substitution, enter a negative value for the substitute fuel quantity and a positive value for the discontinued fuel quantity. So it has a similar feature. Also has examples. Right. Okay, so there is, some of these can be used in both a stationary source and as a mobile source, the crude oil, the diesel. Here we get into jet fuel, air miles traveled, gasoline, values reduced, gallons reduced, or vehicle miles. Similar situation to the air, where you choose either between the fuel or the miles traveled. Again, natural gas can be used in mobile sources. Liquefied, the propane the same, biodiesel the same, and we also have ethanol on here. In this example, let me go back. This again is using an example of substitution, where a chemical company replaced the solvent bonding of plastic parts with ultrasonic bonding, thus reducing the incineration of spent solvents and saving 10,000 therms of natural gas used annually. There's a straightforward example. Another example of this might be where the chemical company replaced 20,000 gallons of distillate fuel oil in a combustion turbine generator with 20,000 gallons of biodiesel. So this goes back to the similar example to what was shown under the Stationary Sources tab. We also have a Greening Chemistry tab. A description of this tab calculates greenhouse gas reductions from reducing the use of high global warming potential chemicals outright, or by substituting with less chemicals with less impact. The tab covers more than 200 chemicals listed by the International Panel on Climate Change, as well as chemicals listed by EPA's Greenhouse Gas Reporting Program. Again, how to use this tab: enter the mass of each chemical avoided for a project, and then the total carbon value will be shown. Calculation description, an example where a company improves their leak detection for their use of sulfur hexafluoride in their own electrical distribution equipment. They save 600 pounds of SF6 for the year. So that you would have 600 pounds entered and see an output of, because that is a very high global warming chemical, the value of the carbon would be 6,396. We have the basic components of the CO2. Our metric tons of CO2 equivalent listed here. Then it goes through the CFCs, the HCFCs, which there are a lot, the chlorocarbons and hydrochlorocarbons, bromocarbons, and so forth. So there's a long list of chemicals here. In this case, the projects are now, because all these chemicals are listed in rows, the projects are listed in columns, so that you can go down and pick which chemicals your project has avoided, and then it will give you a running total of all projects per chemical here. And something that might be used more often, our water management tab. Conserving water lowers energy use to pump and heat water, which reduces greenhouse gas emissions. The energy used to pump water is usually invisible to consumers, so this tab provides a national survey average of the water utility energy used to pump water to treatment plants and through distribution pipes. Note, with respect to heating water, that would be using the electricity management and stationary source tabs. This tab is solely about the pumping and distribution. So pick a state, pick the value of water that has been reduced, and this will give you the associated greenhouse gas reduction that would have been for the pumping and distribution of that water. So in our example, Clean Bio reduced the blowdown losses in boilers at their New York plants through acidification of the water. This saved them 30 million gallons of water, which is equivalent to 102 metric tons of CO2 equivalent. So again, you could pick your state. I'll just pick California. Let's put in the same value and see what the difference is. Oh, I don't know why there isn't. Let's see that N. Oh, it's the same California. Connecticut. For the moment, I don't know why that's not working, but I'll make sure that it is. But it would, because the energy rates, and this would be true on any of the tabs, the electricity management tab, for example, if you put just to see the difference in the underlying fuel makeup that goes into the electric grid in one state versus another, you'll see that you can put in the same values for the units. Here it is only gallons, and you will actually see different numbers under the MTCO CO2 equivalent because the underlying source of energy for states varies. So some are more energy intensive, more carbon intensive than others. Lastly, going to move to the specialty tab, which is infrequently used, but it has to do with solvents that are used in usually the chemical industries that are used for a rather pure purpose chemically, so like reacting, extracting, or blending, such as might go on in a pharmaceutical manufacturing plant or a basic organic chemical manufacturing or plastics and resins or paints and coatings. Those solvents can be reclaimed by going through a distillation column and reused. And so because there was a special project on this at EPA, we have all the values associated with that kind of work, and so we offer it here. So in this example, a paint manufacturer sends 1,000 gallons of acetonitrile to be remanufactured and therefore reused every month for an entire year. So they had 12,000 gallons for the whole year. That was what was sent for remanufacturing, and then converting that to pounds, and then we can see that a large amount of that turned out to be reusable after it went through the distillation process, so from 78 to 71,000, and that has a greenhouse gas value associated with it. And there are a number of tabs after this that explain the background on the calculations that are done on each tab. So I'm going to pause at this point and see if there are anybody would like to talk about anything or ask about anything they've seen here, or any situation that they face in making doing their own calculations for reporting.
Yes, we have a few questions. So one says, have you seen or heard of anyone using this or any of the other tools as a way to prove a project will be successful?
Yes, it can be. So if I interpret that question, and it's a good and interesting question, can we do predictive work in here? Absolutely. I mean, one can estimate that, what you're going to achieve, and come in here and do the calculations and have the environmental impact of what you propose calculated and used as part of your evidence.
Yeah, I think that something that I've always, whenever I look at these tools, a lot of times I think of, just for reporting, but I think that they could also be used to sort of prove that a project will be worthwhile to, maybe upper management or something like that. So
absolutely, and then building in this tool the cost savings aspect. If we just go back to that one, I mean, we don't have the cost saving aspect of every aspect of greenhouse gas impacts, but we do when it comes to electricity management or stationary or mobile sources and water management. So it would be a handy predictive way without a lot of work to show if in fact you are saving money. Sometimes when we do substitutions, it actually ends up costing us more. So you'll see here in some of what we did, it gave us an actual cost instead of a benefit. But then in other areas, it's offset because you're definitely saving money. The value of the water management and so forth. And I would, though, to be fair, point out that for an individual company, the water savings for water management would more likely just show up in the expense of the water, which will be on the next tool we look at, the cost savings tool. This one actually computes the value saved to the water, I guess the water utility, the electricity, well, societally, right, the pumping costs that are not incurred, which I guess is somewhat built into our water costs. But I think the point is real well taken, that this can be used in a predictive way to sell a project.
Yeah, and so let's see, there's Kathy Black. It shows that she has a question, but I'm not able to see it. So I'm going to go ahead and unmute her and see if that she's got a question. Kathy Black, you're unmuted.
Okay, hi. I was looking at the green energy tab, and I just wanted to make sure that it is appropriate if a facility itself installs solar panels, that it's appropriate to use this tab.
Yes.
Okay.
Let's see.
The example was easy energy, so just wanted to make sure it applied to all facilities.
Yes. Right. Our example does happen to have the word energy company named in it, but any facility that absolutely.
Perfect. Thank you.
You're welcome. Hadn't thought of that. Good point. I have to change our example.
And we also have, let's see, Vaughn Cassidy. We've got I'm going to go ahead and unmute you. He's got his hand up for a question.
Good morning, Kathy.
Good morning, Vaughn.
I have a rather sticky question, I think. At least for me, it would be sticky. When a company has increased production, I realize they may be using overall mass balance more of a certain chemical or material, but could they report it broke down by unit of production and say, well, we've actually decreased the use of material or chemical per unit of production, even though we did increase our overall footprint of units or widgets manufactured? Is my question clear?
It is, and it is a good question. And because you folks had alerted me that this was something that has come up, I looked it up a little bit, and it's sort of like it could be a productivity improvement. It could also be that they're just using the capacity of their equipment more fully, and therefore it becomes more economical to use it. It is a topic that I think people have been thinking about for years. It looked to me like it is really helpful to understand the baseline in reporting that, so that there is a way to more or less assess, what we would be looking at to evaluate what we're looking at, because our approach doesn't, EPA's approach, we don't collect that baseline information. We're not set up to report that way, but I will say that in another leadership program that we had been, looking at, I think they did take this approach. They did collect baseline information. They did sort of net out, if you will, if there were some energy savings that could be reported. And I think we more or less took that at face value. We didn't delve down into that and pick it apart. So EPA reporting generally is not set up that way. But I think if something came in to a grantee and they evaluated whether they thought that was legitimate and they passed it along to us, I think we would tend to take that at face value. I did note that people have varying points of view on this, that some stakeholders are less comfortable with it than others. I think it's an area where transparency actually, builds buy-in. So I would think the more transparency around this, the better. The one area that stakeholders seemed not comfortable with is if a facility simply expanded its operations and was able to use its existing infrastructure more efficiently because they were operating more at peak capacity. I think people were uncomfortable with reporting that as an environmental benefit. That said, there are these productivity improvements so that if expansion was going to occur anyway, or the classic example I think that was given, if a new building is going up, clearly that's going to involve energy use that wasn't in play before. But if they build in energy efficiency from the get-go in the beginning of that building, then it's definitely avoiding a certain amount of energy use that would have otherwise occurred. So, that's an example I think people are more comfortable with. So, I don't know if that if I have a yes or no answer. I would just think that being aware of the different aspects of it and being as transparent as possible would be of benefit. What do you think?
Thank you.
Mm-hmm.
All right, I think that, let's see, I'm not seeing any more as of right now.
Okay.
All
right, so we can move to the cost savings calculator. This calculator estimates annual net cost savings realized. So it's possible to come out with a negative net cost savings here, which would mean you've spent more. Anyway, it tries to treat all that fairly. Estimates the annual net cost savings realized from avoided fees and expenses associated with buying fewer hazardous materials, shipping less hazardous waste, emitting fewer regulated air emissions, using less water, sending less wastewater through pretreatment and treatment works, and buying less fuel and energy. Cost differences of buying greener materials, fuel, and energy are also calculated. Users can use the tool to estimate prospective cost savings. Getting back to that earlier question. This calculator is ideal for P2 programs and grantees and partners to use in reporting projects to our P2 program. It converts, so its functionality, it converts activity measures into net dollars saved. And so let's take a look. Again, we have the same aggregate page. The information here is from other entries that I did not erase. That normally, you'd get this and it would be blank and be ready to go for your entries. We start with hazardous inputs and wastes. On hazardous input reduction, the unit, this is one where the user needs to supply the unit because we don't know what hazardous input people are using or what they've paid for it. So this is one of those things where it allows you just to capture everything. A lot of what we do here is, based on a formula and the answer is given to you, but but this would be one where you have to fill it in yourself. So, for example, a cutlery manufacturer replaced trichloroethylene for cleaning. They replaced it with an aqueous, some aqueous wash boxes and an alcohol-based vapor degreaser. So in this case, it was their trichloroethylene. It cost them $2.25 a pound. They had 110,000 pounds. They get to know here, along with everything else they've done, that they saved, 247,000 and change by getting rid of that trichloroethylene. Now, obviously, for them, they paid for the aqueous wash boxes and that vapor degreaser. So this will simply tell you the piece of this, the money they saved, and will continue to save over time, year after year, of buying that TCE. So that's a valuable number to them, and it would be a valuable number for reporting. I will just make a note that in our own reporting model that we put out for 2021 grantees, we now provide a format that allows people to also put down the costs, the one-time costs that they incurred for coming up with their P2 solution. So, that would now give people a place to enter, what they paid for their capital investment in the wash boxes and the degreaser if it was new. But this at least provides you the savings on TCE. Now let's move over to where the units are provided. Hazardous waste reduction. So if we just take a look here, we'll see we have an average across all management methods, and then we break out the methods if they are known, which is if you're not sending something to a landfill, if you're not sending something to an incinerator. Those are more specific. They have more specific values. Now, we provide a default unit cost, and this is, we explain ourselves in our reference tab. These are based on national averages. These definitely stand to be updated. I would think that these numbers are now higher and certainly not lower. We give both a pound value and a gallon value. So you work here if you don't know how the hazardous waste would have been managed. For example, a new process reduced 55-gallon waste drums from 100 to 20. So they, netting that out, that's 80 that they have reduced, and 80 times 55 is there, and the dollar savings associated as a rough rule of thumb, 54,000 and change. Now, if you know it's going to a landfill, you would use that number. Again, you get to, because these are national averages, you don't get to pick your state like we did on the energy tab. So we'll just give you, hopefully this is working. There we go. And then if you knew it was going to an incinerator, you could enter that same number. And see that it costs you, your cost savings is a little higher. Air emissions in our next tab. Computes cost savings for permitted facilities, because this is going to be associated with their paying less in permit fees. So we have our hazardous air pollutants, or HAPs. We have our Title V air pollutants, or what are known as the criteria pollutants. Each of those have state emission tonnage fees, and that's the basis for what we're doing here. We have an other column. You can enter avoided permit maintenance or renewal fees when a facility, so lowers its emission that it can actually, be under a less expensive permitting scheme or get out of permitting altogether. We provide an opportunity to, those would be big savings, and so it's important to remind people that that is a possibility, it's an incentive, and of course if it's achieved, then there's a place here to enter it. So in our example, same thing, where they replace the TCE, and now instead of what were we looking at last time, the hazardous inputs and waste, now we're looking at the air emissions that flowed from that. Their air emissions fell from 110,000 pounds a year to nothing, and so that in permit fees, so it's the same activity. This page computed the out-of-pocket costs to the facility in buying the TCE. Now we're looking at the cost savings they achieve by paying less to the state under their air permit, which is significant. It's a significant cost savings. So, this is one action that had more than one kind of cost savings, and this captures both of them between these two tabs. Another example, sort of a green lodging certification program, and they use lower VOC paints, which VOC is one of the criteria pollutants. It's one of the permitted pollutants. So they achieved some minimal cost savings in their permit by switching paints. All right, let's look at water pollution. So this is again cost savings. This is you'll see the next tab is water use, which is probably what we're all more familiar with. But this is actually the water pollution aspect. So the permit will look at discharges based on chemical oxygen demand. Look at our different categories here. Total suspended solids. These are all permitted categories. Fats, oils, and grease. Nutrients. And we sort of have a default for general wastewater. So to work our way back. State, pick a value, pick a unit. So we do have state-based numbers here, state averages for, again, if anything, these dollar values have gone up because the last time we modified this tool is probably 5 years ago. We have the funding now to update all this information, so that will not take too long to do. So in a relatively near future, these values will be updated. I would be convinced that these numbers are higher, but this is at least captures some aspect of it. This is a wonderful way to reduce pollution, and it's a wonderful way to reflect cost savings. Because the case examples I've looked at, the dollar value of reducing the surcharges for this stuff can really add up savings very quickly. And we have water use, where again we have state numbers and the fees that they charge for water coming to your facility, water coming to your house. So this one is very straightforward. Pick your state, put in your value, and the unit cost is behind the scenes, right? But what will show up is your the result of that calculation. on the back end, and you see the number there. Fuel use. This tab computes the cost savings from buying less fossil fuel and using less for travel. Again, there's going to be a choice here where you pick either the cost of traveling in vehicle miles, which is more or less computed as current, what were then current prices for that, or the cost of the gasoline. Just don't do both. So we have natural gas, vehicle miles reduced, gasoline, diesel, biodiesel, heating oil, jet fuel, air travel, crude oil, coal. And we have default unit costs shown. Here you'd have to put, this is done a little bit differently. Flights avoided. I think here the average unit cost would need to be entered by the user. Like what would that plane ticket have cost? Jet fuel, we have a value. Heating oil, we have a default unit value. Biodiesel the same, diesel the same. Motor gasoline showing at $2.25 a gallon. An average price of 54 cents a mile for driving. And a natural gas value. So in the example here, we don't have examples for all of them, but here, green building reduced the heat usage at 2 commercial buildings by 150,000 therms of natural gas reduced. Shows the dollar savings associated with that. Okay, then electricity use. Conserving and purchasing green energy. So conserving, pretty straightforward. Installing energy efficient lighting, reducing lighting and air conditioning use. Pick the U.S. national or the state value, the amount of kilowatts, again, based on the kilowatt charges of probably 5 years ago. These are the cost savings. These values will be updated in the near future. Trade-offs here between, in terms of cost, between green electricity and conventional. Very often, green electricity is costs more. Now, the value of doing that for the environment, or maybe the long-term sustainability of your business, can reap tremendous benefits. This simply shows you the cost aspect. So in our example, a hotel switched to solar. Their electricity rate increased. So they paid $2,000 more per year for their electricity. So I'm not clear from our example, actually, whether we meant that they installed their own solar panels or whether they were going from that they. So this is so I think not. I think in this case they're purchasing green electricity, right? So they are just their supplier, their underlying source is solar. So their supplier is charging them more for their green electricity. This would be a different calculation. I think if they bought their own solar panels, and it would simply be how much conventional electricity they didn't need to buy, their calculations would occur here. Okay, then we include, even though we don't want it reported to us, that we provided here as a service, we don't So for reducing non-hazardous inputs, it would be a place where a user, if they wanted to do that and they wanted to track everything in one place, the user could enter the produced quantity and they would enter the unit cost. And then this would do the calculation. Here we have just an average cost of reducing solid waste at that price. And the rest of it is our glossary and references. So let's see if there are any questions, Caleb.
All right, let's see. I'm not seeing any in the chat. Yeah, I'm not seeing any right now. Oh, actually, we got somebody raising their hand. Kathy Glappo, you're unmuted.
Thank you. Kathy, I just want to thank you for providing all of the various tools that EPA offers industry for tracking. We at TDEC realize that a lot of our industries have some of their own tracking tools, but we also know that some industries that we work with don't have robust tools to be able to use to track these types of things. So we appreciate EPA creating them, and then also you providing your expertise as to how it works and what various things are out there for them to use. So I wanted to thank you for that, and then providing the service for this to live out on EPA's website for industry that might not have fancy mechanisms and tools to be able to track what they're doing at their facilities. So thank you for presenting on this, and I hope that some of the industries listening in today are able to take some of this back with them and use some of the tools to help them along the way as well.
Well, thank you very much, Kathy. I appreciate having been able to join your group, the workshop, and you know, we always appreciate the opportunity to communicate and keep up contact with everyone in the private sector, in the nonprofit realm, in the governmental realm, who we're all in it together and working towards more sustainability. So it's you know, a great pleasure to be connected to people in this way. I appreciate the opportunity.
Let me check one last time for any questions. Let's see here. Yes, I'm not seeing any. But so if there's no more questions, then I just would like to go ahead and I guess say exactly what Kathy said, and just thank you, Kathy, for taking time out of your busy schedule and for all the work that you've put in for these tools. And you know, they can, when you first see them, they can seem a little bit you know, intense, and you know, you not know what to do. So I'm really glad that we were able to listen to you and sort of run through these tools and calculators, and then also we'll have this recorded, so it'll basically be a resource for all of our Green Star partners and for anybody that has access to our website or to our pollution prevention page. So also I'd like to say thank you to everyone that was a part of the audience. We couldn't do these without having an audience. So thanks for your questions, and thank you for taking an hour and a half out of your day to listen in. And like I was saying, the webinar recording and the slides will be available on our website, and I'll also send those out on with a follow-up email. But if you have any other questions, please feel free to send those to me, and I will get those answered. My email is caleb.powell, caleb.powell@tn.gov. Like I said, I'll be sending out a follow-up email later today. The recording probably won't be out till next week, but that in that follow-up we will have links to these tools and to the page, and also we'll give contact information for Kathy just in case you have any more in-depth questions that you didn't get to ask today. So without that, thanks again, and have a great rest of your week.
And thank you, Caleb, for moderating everything. Really appreciate it.
No problem.